Hi everybody, my name is Sidney Semenza, and today I will be talking to you about the habitat preferences of the intertidal octopus, Octopus Oliveri. So my main goal for this study was to determine the overall habitat preference of this species, and I did so by describing the relationships between octopus presence, substrate composition, and tides. So intertidal habitats have always been really important in marine science, and some of our most important theories of the 21st century arise from intertidal work. So predation by pain and the keystone species are both, and biconal are both originating from intertidal work. And in Hawaii, they're both culturally and economically important habitats. They provide both recreational, commercial fishing, and they also help with erosion from heterogeneous sediment as well. The Hawaiian intertidal, however, is vastly understudied. So temperate regions are a lot more studied, so we understand the driving factors of those systems a lot more. And the tidal range in Hawaii is a lot smaller than we see in temperate ranges. So some people do not see it as a distinct zone, but regardless, it is a very biologically rich environment and supports over 600 species. So one of those species is the octopus, usually found as a keystone species, which essentially means that their presence ensures the overall health and functioning of an ecosystem. They're also culturally significant and mentioned several times in the Hawaiian creation chant. But despite their importance, over half of the species in Hawaii are undescribed. So there are 15 species of octopus in Hawaii, but only 6 of them are described. And while my species, Octopus Oliveri, is described, it's overall underrepresented in the scientific literature. And while other studies have hypothesized that they prefer rocky substrate, there is no one study prior to this one that looks at their specific habitat preference. So my predictions for this study was that the differences in substrate composition, tide phase, and amplitude would influence the occurrence of Octopus Oliveri on the southern shore. And from these predictions, I formulated 2 hypotheses, the substrate preference hypothesis and the tide phase preference hypothesis. So into the methodology, here's a little example of what it looks like when you're looking for them in the intertidal regions. They are quite small and quite hard to see. They do like to burrow and hide in little crevices. This is the overall location of all the surveys. That green line that we can see on this figure here is the location of where I was walking along and looking for them in the rock jetty part of Kewalo Basin. So the sampling procedure was relatively simple. There were 40-minute surveys, 1 hour after sunset. I ended up having 12 surveys, so 6 in the high tide and 6 in the low tide. And essentially what would happen is I would find an octopus and set down a quadra. And a quadra is essentially a tool that helps you quantify the percent cover of a specific region. And so I would compare an octo quadrat with a control quadrat, which was taken from the same region. And setting my sampling up in this way allowed me to have an equal sample size between octo and control so that I could compare them directly. So this is the location of where I found all of the octopus. None of the octopus were found in the exact same location each time. And so I think it's interesting that they're all concentrated to the same general region of the basin, but they were never found in the exact same location. So that I thought was an interesting tidbit. So going into our results, unfortunately, the tide phase hypothesis was insignificant. However, there were some interesting trends that we will talk about in a little bit here. So the substrate preference hypothesis was partially supported and led me to an alternative hypothesis. So instead of the original hypothesis of rock and biotic being favored, the results indicate that rock is significantly favored. Biotic has no real difference between octo and control, and that algae is highly avoided by the octopus. So in our tide phase preference, you can see that although this relationship is not significant, there is an opposite trend of occurrence and tidal amplitude in each of them. So along our x-axis here is the tidal amplitude in meters, and the y-axis is the number of octopus present. So within the low tide samples, or our pink series here, you can see that occurrence increases with decreasing tidal amplitude, while the opposite trend is seen in the high tide. So our substrate preference, our paired t-test, our purple series here are going to be all of our octopus samples, and our green is our control. So the significant values that we got from this paired t-test were for both rock and algae. Rock was anywhere from 2 to 8.5 counts higher in octopus samples, and algae was anywhere from 1 to 9 times less counts in octopus samples, or that there's always more algae in the control samples, which suggests that they are avoiding algae. So a little bit of discrepancy between my study and other studies is that other studies cite a heavy influence of tidal amplitude and wave energy. I did not find this relationship to be significant. However, as mentioned before, none of these other previous studies are looking particularly at the habitat preference, and my sample size was a bit small. So either of these could be an explanatory factor for that. However, I was able to confirm the previous suspicion that the rock octopus confirms rocky substrate, and I was able to describe a new relationship to algae. As far as I know, none of the previous literature speaks on this specific specimen or species having an aversion to algae. And it is interesting, another intertidal rock-dwelling octopus in Northern Australia, actually named the algae octopus, does not seem to have this aversion to algae. So this does raise the question in future studies of what is the relationship between algae cover and Octopus oliveri? Does algae growth negatively affect it? And as both octopus and algae cover are expected to expand within the next century because of global sea temperatures rising, the interaction between them could either, maybe there's no interaction at all, or there may be space competition between these as well. So in order to determine this relationship, we first need to establish a baseline population record, just so we can track changes and see anything significant happening. And if there is a negative impact of algae growth on Octopus oliveri, then there are possible ways to deter growth of algae in these intertidal systems. So I would like to say thank you to all the fishermen, my friend Boyson, and Marine Life Photography for allowing use of their photo, and additional thanks to Dr. Heirbach and Dr. Yaki for their help in the field.